Welcome to this rapid fire battle between two titans of programming, synchronous and asynchronous execution. Think of it like a time management face off in your code. One is about waiting your turn and another one moving ahead smartly. By the end of this session, you will know exactly when to use each and why it matters for app performance and user experience. Let's understand what is synchronous and asynchronous in a very quick manner. Let's get into synchronous. What is synchronous? We are beginning with this synchronous model. Here, tasks are performed one after another. Each task waits for the previous one to finish before it can start. This approach is simple, predictable, and easier to debug. But it is also blocking, which means nothing else can happen until the current task completes. Synchronous is perfect when things need to happen in order, like the calculations, step-by-step logic, or reading files in sequence. Let's get to the next one. What is asynchronous? Now, neat asynchronous type, designed for efficiency and responsiveness. Here, tasks can run independently without waiting for others to finish. The code moves ahead while some tasks are still pending. This is incredibly useful for things like API calls, database queries, or file I/O, where waiting would waste resources. Asynchronous programming is ideal when you want a snappy, non-blocking app like real-time systems or web apps. We need an analogy for everything, and here it comes. Let's simplify this with a quick analogy. Synchronous is like standing in a physical queue at the bank. You do nothing but wait for your turn one after another. Asynchronous is like taking a token, going shopping, and coming back when your number is called. You are not blocked, you are doing something parallelly useful in the meantime. This analogy helps you visualize the time efficiency advantage of asynchronous coding. Let's compare both the styles head to head to see how they differ in real world coding. First one is execution flow. Synchronous runs step by step, one task finishes before the next one. Asynchronous is event driven, allowing tasks to progress without waiting, enabling parallel operations. Wait time is the next one. In synchronous code, the wait time is high because each task blocks the next one. Asynchronous allows you to multitask, reducing the idle time. Complexity. Synchronous is very simple and intuitive, great for quick scripts and learning. Asynchronous needs callbacks, promises, or async await, which adds complexity but enables powerful concurrency. Use cases. Use synchronous for small predictable tasks, the scripts, file reading, linear logic, etc. Asynchronous shines in the I/O heavy apps, API calls, UIs, and servers where speed and responsiveness matters a lot. Choose wisely.